Hello, this is Bill from What Kind of Math Is This? In today's tutorial, we are going to talk about how to compare the rate of change dealing with functions, whether it's a coordinate plane, a graph, or with a table, or a coordinate plane with an algebraic equation. I got two examples I want to go and cover for you, so let's go ahead and get started. The first one, of course, is going to be a coordinate plane and a table. And to determine the rate of change, we need two established points in each. So let's go ahead and look at A. A, of course, is a coordinate plane. And I have, let me make a little table here, help myself. I have Y, which is my input. I'm sorry, X, which is my input, Y, which is my output. And for those, I'm going to need at least two established points. So I look here and I see this one here. And of course, I see this one here. So this one, the first one is going to be 1, 2, 1, 2. That's also known as a coordinate pair. And the second one is going to be 2 on the X and 1. So 2, 1. So I look at my rate of change from 1 to 2 and ask yourself, what is 2 minus 1, or 1 minus, however you want to say it. And of course, it's going to be 1. So the rate of change on X is going to be 1, and the rate of change on Y is going to be 1 as well. And the way that we would determine the rate of change is that we would put Y over X, and then you can see that the rate of change is 1. So the rate of change for our coordinate plane A is going to be 1. Now we're going to compare that to the table that we have, the function table that we have, and determine what is the rate of change there. So all we need are two fixed points. It doesn't matter if it's this and this, or this and this, or this and this. We're just looking for 2. So what we're going to do is we can just take these two and these two, and we look for the difference. Difference between -9, -2, or -7, of course, is 2. And the difference between this 13 and this 11, of course, is 2. So Y goes over X, divide the top by the bottom. And as you can see, the rate of change for number 1, the coordinate plane is 1, and the function table, if you will, is 1 as well. So the rate of change is the same. So that's all you do for that. Now let's go and look at number 2. And of course, let me get rid of that to make it simpler. We don't get confused. All right, we'll come over here and look at A. We are going to need X and Y, so we keep that straight. And we just need two fixed points. So I'll take, let's see, there's 1 and there's 1. I'll take this one first. That's going to be a -2. 1 for the Y. This is going to be a -1, and for the Y, this is 1, 2, 3. That's going to be a -3. So determine the change. Of course, the difference is going to be 1 here and 2 here. It's going to be 2 over 1, or 2. So the rate of change for this coordinate plane is 2. Now we come over here and look at this one, and as you can see, you have an algebraic equation above it. It is 8x times, or 8 times x plus 9. If we want to simplify that to help our, just help us visually, just go ahead and combine this. 8 times x, of course, is 8x plus 9. All right, so we can already tell that the rate of change is going to be 8, because if we use the formula y equals mx plus b, we would see that 8, of course. But we'll go ahead and do what we were starting off with, and I will compare. The rate of change between -1 and 0 is 1, and the rate of change on this and this, of course, is 8. Y over x, and the rate of change is 8. So remember, the first one for the coordinate plane was 2, and this one is 8. So B would be our answer. B would be our answer because it has a greater rate of change. It has a greater rate of change. And just to clarify, what I mean exactly by that is the change in position from one point on X to the next point, and same thing for Y. Anyway, this is Bill from What Kind of Math Is This? I hope this shows you how to determine or how to compare the rate of change using whether it's a graph, function, algebraic equation. So if this video helped you, please remember to like it. And thank you very much for watching, and have a great day.